Welded joints are connections between two parts that are formed by welding. Welding is a process of joining two or more pieces of metal by heating the surfaces to their melting point and fusing them together. Structures is critical to ensuring that the structure is safe and meets design specifications. This may include visual inspection, X-ray inspection, ultrasonic inspection, and tensile testing. By considering these key elements, engineers can design welded structures that are strong, reliable, and safe for their intended use. There are several types of welding techniques, each with its own unique advantages and disadvantages. Some of the most commonly used welding techniques include shielded metal arc welding, SMAW, also known as stick welding. SMAW is a manual welding process that uses an electrode covered in a flux to produce the weld. It is versatile and can be used on a wide range of metals, but it is typically slow and requires a high degree of skill to produce high-quality welds. Gas tungsten arc welding, GTAW, also known as tungsten inert gas, TIG, welding. GTR uses a tungsten electrode and an inert gas to produce the weld. This welding process is typically used for precise welding on thin materials, but it is slow and requires a high degree of skill to produce high-quality welds. Gas metal arc welding, GMAW, also known as metal inert gas, MIG, welding. GMR uses a consumable wire electrode and an inert gas to produce the weld. It is a fast, efficient welding process that is commonly used in industrial and manufacturing applications. Flux core arc welding, FCAW, similar to MIG welding, FCAW uses a wire electrode with a flux core instead of an inert gas. It is a fast and efficient welding process that is commonly used in heavy industrial applications. Submerged arc welding, SAW, uses a continuous wire electrode that is fed into the weld pool, which is covered by a blanket of flux. It is a fast, efficient welding process that is commonly used in heavy industrial applications. Electroslug welding, ESW. ESW uses a consumable electrode that is melted and deposited into the joint by an electric arc. MIG welding, require larger weld sizes to produce strong, high-quality welds, while others, such as MIG welding, are more efficient and require smaller weld sizes. Code requirements, welding codes and standards, such as the American Welding Society, AWS, D1.1 code, provide minimum requirements for weld size and reinforcement. These requirements must be followed to ensure the structure is safe and meets design specifications. Once these factors have been considered, the size of the weld can be calculated using mathematical formulas and engineering calculations. It is important to work with a qualified engineer or welding specialist to ensure that the weld size is calculated accurately and meets the requirements of the project.